Hello everyone, this is KP the Math G once again. We don't have a 2025 problem. I've got a lot of books, workbooks, textbooks, so I'm picking out some problems. What we're really working on, I'd like to work on a couple of related rates, if you will. And so we're going to work with one that's probably not as familiar. You know, you've probably seen the one with the ladder leaning against the wall, and the ladder is sliding down the wall and kicking out. Well, that's the most common one. Sometimes you might have the length of a shadow, and then so on and all that, and the rate of a shadow lengthening or decreasing or whatever. This one here is dealing with a rocket, and so we're going to talk about that one. Okay. Let me stand off to the side where you can see this. I don't have much room in my room here. We're going to make room if we can. It says a rocket is rising vertically at a rate of 5,400 miles per hour. An observer is standing 20 miles from the rocket's launch point. How fast is the angle of elevation between the ground and the observer's line of sight increasing when the rocket is at an elevation of 40 miles? Now the answer, I think it does say how fast in radians per second. So we are dealing with radians per second. Okay, that's what we're wanting to do. We have this rate of 5,400 miles per hour. Sorry, 5,400 miles per hour. But we want this to be in seconds. Now, it is interesting to note that this is in miles and this is in miles. But you have to be very careful. I'm pretty sure maybe on the test that you're going to take, you may not have to make a revision from miles per hour to miles per second or something like that. So in this particular case, we're going to have to get this in seconds. So you have to understand what is the answer calling for, So let's kind of paint a picture first of all before we get into all this changing from one thing to another. We're going to have to go back and forth, I'm sure. Okay. I think I got a picture of it written down. So here's the general picture. Here is an observer right here, standing here, and this line of sight is changing. Okay, it's this rocket has launched. This person is 20 miles away. Okay, and here's the rocket, and I want to say they use the letter H. We could use the letter Y if you want to, but I'm sticking with H. And we're going to actually form a triangle. Theta is here, like this. Okay, and what we're dealing with is this line of sight. How fast is this increasing? Okay, and that's what we're looking at. So we're looking at d theta over dt. When it says how fast is this increasing? Well, when we're dealing with this now, we must understand that when we're looking for, and we got theta involved, we might need to look at sine, cosine, or tangent. Remember that tangent, though, is opposite of theta is over here. Adjacent is here. So adjacent is here. We know this is adjacent because opposite of the right angle is the hypotenuse. Well, we're not interested in the hypotenuse. We're just looking at the opposite over adjacent. So obviously we're going to look at tangent. So let's look at that. Okay, so tangent of theta is equal to h over 20. Alright, so what we have to do is, we have to, now remember 2, and we're going to get into it, we know actually that dh over d, well, that's what we're looking for, d theta over dt. We know that dh over dt now let's go back over it again. I'm sorry we're going back and forth. My board's just not wide enough. I've got so much stuff in this room. Alright, it's rising vertically at a rate. So it's going vertically upward. So dh, h is the height. So dh over dt. If it were y, we would say dy over dt. It's going up 5,400 miles per hour. Alright, so this is what we have to contend with. dh over dt is 5,400 miles per hour. Now I said write it in radians per second, so we at least need to get hours in the second. Now one thing that you can kind of keep on the top of your mind is that when you're converting something over, sometimes you might do good to memorize that there's 3,600 seconds. And I'm sorry, it's the other way around. 1 hour is 3,600 seconds. Okay. So I know that, see, you want to fix it where you don't want to put your 3,600 up here because you want the hours to divide or cancel out. So they do. So now we got it in miles per second. But now we've got equal to 5,400, and this is over 1, and then 1 times 3,600 is 3,600. And that helps to know right there. There's 60 minutes in an hour, and then there's 60 seconds in a minute. So you can do it that way if you wanted to. Alright, so this is miles per second, but anyway, let's not worry about the units. 54 over 36. We could divide both sides by 18. I know 9 will go, but since I'm just kind of thinking, I'm thinking 9, but it will be 18 if you wanted. If you didn't see 18, you could do 9. 54, 9 into 54 is 6 times 9 is 54, and then 9 into 36 is 4. And then we can divide by 2, and then we get 3 over 2. So this is now in miles per second right here, isn't it? Alright, so dh over dt is the same as 3/2 miles per second. Alright, there we are. We do have the seconds, and that's basically what we're, so where's the radians going to come in? When we do some figuring here. Alright, we've done all this. Can I do want to erase this now. That's the first thing I did not think to do, is to convert this into seconds. But then I got to thinking, wait a minute, whoa, the problem does call for radians per second. Eventually, something's going to happen with our miles. Probably they're going to cancel out and we're going to have radians per second, just as we want it. Alright, so now, we want to do this by related rates. We must take the derivative of both sides. Alright, derivative of tangent. Believe it or not, it is secant squared. I could go through and show you that this is true, but we're going to just go ahead with this. Now remember, when we take the derivative of this, we've got to take the derivative of this as well. So times, so d theta over dt. And that's really what we're looking for right here. Times that, okay? Now the derivative of height is just dh over dt. We can make this, by the way, we can make this 1/20th h, can't we? So we can make it 1/20th. Derivative of h is 1, but that's just times dh over dt. Okay, now we already have that. That's going to be 3/2. Alright, so secant squared times 1/20th times 3 over 2. Alright. And so what we have here is, I might have room, let's kind of divide it up here. So we're down to secant squared is equal to 1 times 3 is 3, and 20 times 2 is 40. Now, it would be nice if we could figure out something. Oh, I left off something very important. D times d theta over dt. Whoo, we can't leave that out. Now is equal to 3 over 40. Now, let me explain something to you here. We may have to erase some of this as well, but at least we got it down to here. Okay, now, one thing that I know is that at the moment, we've got to go back and flip our board back over. Taking a little while for this one, isn't it? Now, how fast is the angle of elevation between the ground and the observer's line of sight increasing when the rocket is at an elevation of 40 miles? So we don't plug in 40 right away. And that's something you need to understand. We do not plug in that 40 right away. So now if we do that, alright, h is 40. Now we can plug it in after we've taken the derivative. Now we've got tangent of theta is equal to h over 20, which is 40 over 20. So we got this on the side here. I'm going to need this space. I'm sorry, I'm just going to have to erase this. Alright, there we go. Now tangent of theta, and I'm going to show you why I'm doing this. Opposite over adjacent, 40 over 20, tangent of theta. Now, that's important. 40 over 20 is 2, we know that, right? That's important. Will you get one like this on a test? I don't know, maybe in parts. I don't know. This may be a multiple choice, but I like to just show you how to do it anyway. Now I know something that secant squared is. Okay, I'm looking for secant squared. So I know that tangent squared, a little identity, and plus 1 is equal to secant squared. So now I know that. Alright, so I think that's right. Yes. Yes, I'm right. So if we were to take this right here now and square both sides, then tangent squared would be equal to 4. 2 squared is 4. Oh boy. Secant squared theta. Boy, that's a tough. This is not one of the easier problems, I promise you. Now in place of secant squared now, I can now put 5. 5 is equal to secant squared. So 5 times d theta over dt. Oh boy, that, yeah, and then I'm going to divide by 5 or multiply by 1/5. Notice that goes out, and now d theta over dt, ooh, is equal to 3 over 200. And if you look at this, you probably see that there is going to be, it's going to be in let me see what I'm talking about, radians per second. And this is always in radians here. So the top number's in radians now per second. Alright, there it is. Wow. And you know, I know I erased a lot of stuff here, and I know we had to use some other techniques to get this here, but we had secant squared, so it was only natural that we solve for secant squared if we could do something like that. So secant squared is tangent squared plus 1. Now, I know, will we think of that? Maybe not. Okay, and then of course tangent theta is 2, so tangent squared is 2 squared, which is 4, and 4 plus 1 is 5. So in place of secant squared, we just put 5 here. 5 times d theta over dt. We multiply them by 1/5, and then we get 3 over 200. Radians per second. Just kind of a problem like that, you know, that would come up. I don't know if that is even, I know it is an AP question, that's all I know. And so it is a really nice little problem to look at. It's something to get you familiar with right there. Okay, anyway, this is KP the Math G. Getting ready to sign off. Please hit that subscribe button if you have not already. Please feel free to make a comment if you'd like to, positive or negative. Just make a comment. And if you make a negative comment, please tell me why or what's your reasoning behind that. And if you hit the like button, that'd be great. If you don't do any of those things, that still would be great, because again, this is more for you, and I just hope I did not muddle things and make things wow. But I do think, if anything, that you do need to know that if this thing called for radians per second, you need to get this per hour. You need to change that per second. and we knew that that was 36, that there are 3,600 seconds in an hour, so you could eliminate your hours doing that. And then this little identity here helps to square both sides. 4 plus 1 is 5. In place of secant square, you're putting 5, just the number 5. A little bit of you know, maybe I'm pretty sure maybe if anything that you would already get this given to you, so you would not have to convert this. Would you need to do this? I don't know. But again, this derivative of tangent is secant squared, so you really would like to figure out what secant squared is equal to. And so we had to use everything to get everything there. Alright, this is KP the Math G getting ready to sign off. Ladies and gentlemen, have a great day.